Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. I am Mr. Sanaul Nahan, lecturer in Computer Science, Institute of Computing, Cohort, University of Science and Technology, Cohort. I am the instructor of course Computer Graphics, CS443. Today I want to deliver the lecture number 7. Topic is DDA line driving algorithm. So this is the objective of the today topics. To understand the basic concept of line driving algorithm, to study that how line is drawn. Raster display means two-dimensional display x and y coordinates. To understand the mathematical background of DDA line algorithm. This is the outline. Computer graphics hardware, problem of scan conversion, consideration, line equation, scan converting algorithm, a very sample solution, and second one is the DDA algorithm. So after that, conclusions. This is the list of recommended and reference books. This book is recommended. The 4th edition of Computer Graphics with OpenGL, Heron, Becker, Cartier's 4th edition, and these two are the reference book. So before starting towards the line algorithms, little bit we look towards the how graphics hardware works before we go any further. How do things end up on the screen? This is the modeling coordinates when each separate object are created, models and 2D, then this is called as model coordinates, and these two models combines are more than two models combines, objects combined, then become a scene. So scene is the combination of multi types of objects which are combined in world coordinates, and these are again viewing and projection coordinates, which is also called view coordinates, and then normalized coordinate and single window to normalize which one will be displayed and separate each objects on scene, and then transfer these objects to the video monitor, plotter, output device, etc., which is also called device coordinate. So the basic architecture of graphics system is, as we know, that computer internal parts are normally connected with a system bus. System bus carry different types of data which are sent and received by different types of internal computer devices like CPU send data to system bus and receive data from system bus. Same is the case as display processor send to system bus and receive same system memory. So display processor are having contains small type of memory and the frame buffer which combine the bits of different types of graphics, and after that combination and send combined data to the video controller and then to the monitor. So there are different type of output devices which are used in graphics like printer, plotter, cathode ray tube, plasma display, LCD display, 3-dimensional viewer, virtual augmented reality. So we'll look briefly at some of more common display devices. This is already discussed in the lecture 2 with detail. So drawn line, one line at a time on the screen will be started the pixel and XY coordinates from top left corner to the right up to bottom. Pixel are drawn on the screen, and those pixels are shown to the user, to the viewer, which are having intensity high. So here the red color intensity is high, other pixel are normally we can say it is the background pixel. Those pixel having intensity high is called as foreground pixel. So what is the main problem of scan conversion? If we draw a line on the page and then we convert same line to the computer or mobile screen. Then in computer mobile screen, it will be displayed in the form of x and y coordinates, which is also known as pixel. So let's suppose this is the line. Its start point is 2 2 and end point is 7 and 5. Means that is the x initial point, this is the y initial point, again this is the x end point, and this is the y end point. So if we draw this line on the graph raster display, then it will be look like this. So 0 1 2 3 up to so on. So on x y, when x coordinates value 2, then the y coordinates values become 2. So 2 comma 2, and then if x value increase by one interval, means it become 3. Then the y value, what will be the result of the y value? So if it increase with the interval of 4, then what will be the result of y? So up to e. So question is this: here 2 pixels are same, and here also 2 pixels are same. How line is drawn from this pixel to this? This is the problem. Then we are how do we choose which pixel to turn on? This one or this one, this one or this one? So it is a big problems. So consideration, our consideration is when we want to develop a line drawing algorithm, is the line has to look good where the jog is. It has to be lighting fast. How many lines need to be drawn in the typical scene? So we know that about the line equation. Quickly review of line equation, which is also called the slope interception line equation, which is equal to y is equal to mx plus b. Means that y coordinates depend on the m means slope, and x and b arbitrary values. So y coordinate will be calculated from this equation. So we are m is equal to y end minus y naught divided by x end minus x naught. Y end means y end point, and y naught y initial point, x end point and x end point. So b is equal to y naught minus m dot x naught. So after that, slope, line and slope, each line having a different slope. It start in each coordinates. Maybe some lines having a same 2 or more than 2 lines having a same slope. Let's suppose this is the line having a same slope 0 and 0. This is the line 1.3, this gave minus 1.3. So it's possible. So a very simple solution. So we could simply work out the corresponding y coordinate for each unit x coordinates using the line equation. If this is the x coordinate 2, then corresponding y coordinates become 2. If at x increase with unit interval, it become 3, then what will be the corresponding y coordinates? So if up to last end points. So if 2 start end points are given, then how we can find the intermediate points using a line equation? So this is then a small example. So first of all, if we want to find out the intermediate points from which start and initial point is given, then first of all, using line equation, first of all we want to calculate the m. So m is equal to y end minus y end minus y naught. Y end is equal to 5 minus y naught is equal to 2 divided by x end and x naught. In 7 means 7 minus 2, which is equal to 3 by 5. So b is equal to y naught minus m dot x naught. So y naught initial value is 2, m value is 3 by 5 multiplied by x naught value 2, which again is equal to 4 by 5. So these points are computed. Now we can easily calculate the y corresponding coordinate with x. So now for each x value, work out the y value. So if we want to calculate for we can see that if x coordinate is 2, then what corresponding y coordinate is also 2. So if x coordinate become 3, then what will be the corresponding y coordinates for y3? So this is the equation mx plus b. So m value is 3 by 5 multiplied by x now increase from 2 to 3, so 3 plus b 4 by 5, which gave us the value 2 and 3 by 5. So for same is the case for if x increase again to 4, then what will be the corresponding y value of 4? So 3 by 5 multiplied by 4 plus 4 by 5, 3 1 or 2, same is the case of 5 and 6. After that, because pixel is not divided in the points value, it must be integer, so we can convert this value into approximately equivalent value. So 2 3 by 5 approximately equal to 3, 3 1 or 5 approximately equal to 3, 3 4 by 5 again approximately 4, and this is also a 4. So now if we want to display and draw this line on raster display, then how it will be look? So if x value is equal to 2 x coordinate, then y corresponding coordinate become 2. So this points draw on this pixel will be drawn this points. So if x increase with the unit interval, it become 3. So if x3, then corresponding y become 3. So if x4, the corresponding y again 3. x5, then corresponding y again 4. x6, then corresponding y again 4. if x7, then corresponding y become 5. So problem is this, that there are two pixels are in same location, same is the case this. Now if we want to draw the line, then which one pixel will be turned on and which will be turned off. This is the main problem. So for this problem solution, different types of algorithm are introduced which want to try to overcome the problem of joggies, to overcome the problem of different type of pixel. So very simple solution. However, this approach is just way too slow. It's practically look out for, because when we want to calculate m value of b, then after this calculation we calculate the value of y, and then rounding a figure. So it is too much time consuming. So we need a faster solution. For that purpose, the DDA algorithm has been introduced. DDA stands for Digital Differential Analyzer algorithm. Task takes an incremental approach in order to speed up scan conversion. It increments xy with the unit interval, and same is the case y values with the x value with unit interval and y value with the unit interval. Simply calculate yk plus 1. yk plus 1 means y initial incremented value based on the yk, which is the previous one. So consider the previous example points which we calculated. So initial points 2, 2 and end point 7, 5, and these are the intermediate points. Notice that when x coordinates go up by 1, it means x will be increased by 1, 2, 3, 4, 5, 6 and 7. Then y coordinates simply go increase by the slope of line, like this and this one. So this is the key insight in the DDA algorithm, that it remove this problem. So the DDA algorithm mostly depend on the slope. First of all, we can compute the slope. If the slope value is less than 1, then we simply increase the x with unit interval, and y will be calculated using this equation. So yk plus 1 mean y in incremented value, it means y next value will be is equal to yk, y previous value, plus m slope value. So sometime if the slope not equal to 1, means it is greater than 1 positive value, then the rules become changed. It will be the reverse of the first one, in where y value will be increased with the unit interval and x value will be increased with the slope. xk plus 1, x new value will be x previous value plus 1 over m. So if the case is different, that x and the slope value is equal to 1, then simply x will be increased with unit interval and y will be also increased with the unit interval. So this is the example, that if here that is the x and yk, and this is the further x and yk, If x is increase with unit interval, then the y value be rounded. If x will be increase the unit interval, and the y value will be rounded. If both are means xk plus 1, yk plus x, y value will be increased with the slope. So in another scenario, if x slope value is greater than 1, mean positive, then the y value will be increased with the unit interval, and x value will be increased with slope value. So if we want to write a code or program for this, then the pseudocode is given below. First of all, compute m. If m is less than 1, then y naught value will be assigned to y initial value, and x will be increased with a unit interval in x plus 1, and y value will be rounded. If condition is different, m value is greater than 1, so y will be increased with a unit interval, and x will be increased with a slope value. So example 1, here we use a DDA algorithm to draw a line which starting point is 2, 0 and 7, 4 on a pixel build display. So first of all, we will compute the slope value, which is equal to y end minus y start divided by x end minus x start, means y end value 4, y start value 0 divided by x end value 7, y and x initial value 2. So 4 minus 0, which is equal to 4, 7 divided by 7 minus 2, which is equal to 5, 0.8, which is less than 1. So when a slope is less than 1, then x value will be increased with unit interval, and y value will be increased with a slope. So x value y is equal to y start, which is 0 initial value, and x is equal to x start, which is 2. So x will be increased with unit interval in plus 1, x will become 3. So this is the x, y, and this is the rounded value. So if x value is equal to initial value, x value is 2, y initial value is 2. Okay, so if x because slope is less than 1, x will be increased by 1, it become 3, and y will be increased using the equation of slope. So y is equal to y plus m, y previous value plus m means slope, y initial value or previous value is equal to 0, or slope value is equal to 0.8, which becomes 0.8, rounding it, and then finally y corresponding value become 1. Now if you want to calculate the next value, so the y original value will be applied, put here, and the previous value, not the rounded value. So x will be again increased with unit interval, it become 4, and y will be increased with a slope. So y plus m, now y initial value, previous value is 0.8, or plus slope value 0.8, so it become 1.6, rounding it, and then become 2. X will be increased with unit interval 5, y will be increased with the slope. So y plus m, y previous value, which is 1.6 plus 0.8, 2.4, and it become 2, and then 3. Finally x increase 7, and y also available, which is 4. So if we want to draw this pixel on the screen and display, so if x value is 2, then corresponding y value is also 2, corresponding y value is 0. So if x increase with the unit interval, it become 3, then corresponding y value will be 1. If x increase with the unit interval, it become 4, then corresponding y value become 2. X become 5, corresponding y become again 2, x become 6, corresponding y become 3, x become 7, corresponding y become 4. So look toward this, let's eliminate the remove, not completely, but eliminates the 2 pixel which become on same points. In the previous example, we see that 2 pixel become on same point. Here we can remove 1 pixel and will become again. So the when line draw, it will be started from here and it will be ended. So again one problem is remaining, that which pixel will be turned on and which will be turned off. So this is the second example. Draw a line between 2, 1 and 6, 9. x initial value, y initial value, x final value, y final value using DDA algorithm. So calculate, first of all we want to calculate the slope, which is equal to delta y divided by delta x. Delta y is equal to y2 minus y1 divided by x2 minus x1. So y2 means 9 in end value, minus y1 1 divided by 6 minus 2, which is 2. So slope become 2, which is greater than 1. So the second condition become true, where x value will be y value will be increased with unit interval, while the x value will be increased with the slope value. So this formula is used, xk plus 1 over m comma xk plus 1. So 1 over m is equal to 1 over 2, which is again is equal to 0.4. So x y value, x initial value is 2, y initial value is 2, x will be plot 2, y will be plot 2. So finally coordinates will become 2 comma 1. So x value will be increased with the slope value. So xk means x previous value, which is 2 plus 1 over m, which is 0.5. So 2 plus 1 over m, 0.5, again become 2.0. Then x rounding it, then it become 3. X will be plot 3 and y will be increased with the unit interval. So yk plus 1, y previous value, which is equal to 2. 2 plus 1 is equal to 3. Then it will be plot 3 and final coordinates will become 3 comma 3. So after that x value again increase. So xk plus 1, xk, now xk value is 2.5. So 2.5 plus 0.5, it become 3, and yk will be increased with the unit interval. So yk previous value is equal to 2, 2 plus 1 is equal to 3, then 3, x will be plotted 3, y will be plotted 3, final coordinates 3 comma 3. Same as the case up to e. After that calculation, it gave us the line points 2 1, 3 2, 3 3, 4 4, 4 5, 5 6, 5 7, 6 8 and 6 9. So try to solve these two tasks. To draw a line with the starting point 20 and ending point 67 on pixel based display. So consider the line from 00 to 66. Use the simple DDA algorithm to rasterize this line. So the DDA line algorithm summary is much faster than our previous attempt. Practically there is no longer any mathematical multiplication involved, no mathematical calculation involved. So there are still two big issues. Accumulate of round error can make the pixelized line drift away from what was intended. The rounding operation and floating point arithmetic involved are time consuming. So conclusion, draw a line to pixel based display is time consuming, so we need a good way to do it. So the DDA algorithm is pretty good, but we can do better to find out some other algorithm which perform better than the DDA algorithm. Thanks.